Okay, how do you do number 17? Brendan?
Okay, so first to start off, you eliminate the parentheses, so you do power of 4. You do 3 times. You do 4 times. You distribute the product.
Okay, so we're distributing the exponent?
Yes.
All right, what happens with the negative sign?
It just stays there.
It stays there? Okay, so then this becomes 4 to the,
Third power.
and m to the,
Third power.
okay. All right, I'm going to keep this in parentheses until we do what with the 4 to the third?
Until you solve it.
Good, what is 4 to the third power? 64, so that's 64m to the third. And then what happens with this negative? Negative is still out here, because the negative on the outside of the parentheses means that your answer is going to be negative. Okay, keep in mind, an exponent distributed does not mean 4 times 3. It would be 4 times 3 if you had like a whole number constant 3 to the outside of the parentheses. Since it's an exponent, that distributes. All right, and then with number 4, what do you do for number 4? What do you do for number 4? Add them together? How come? Because it's a multiplication problem, and the bases are what? The same. So if you add together -6 and -1, what do you get? So it'd be q to the -7th, only I can't leave it like that, so what do I get? 1 over q to the 7th. Good. It's similar with number 7, except with number 7, what do I have?
You have 2 different variables.
Okay, so my 2 variables are, so it'd be c to the 8th and b to the -2, but I can't leave that like that, so what happens there? All right, so you can write it 2 different ways. I saw people write this 2 different ways. C to the 8th times 1 over b to the 2nd is fine, or c to the 8th over b to the 2nd is also fine. Okay? C to the 8th is going to stay on the top because it's got a positive exponent. Yeah?
So you can't do c to the 8th plus b to the 2nd over 1?
No, because b has to be in the bottom since it's a negative exponent. So you got to move it to the bottom. B to the 2nd over 1 would assume that b were positive. Okay, so we talked about multiplying and then powers to powers, and today we're going to talk about dividing. So what do you think we do when we're dividing with exponents? Subtract. Why? You're right, we do subtract them. As a shortcut, we subtract them. Why do you think that works, though?
Because when you're multiplying, you're adding.
Okay, when you're multiplying, you're adding, so it's probably the opposite. What would this look like if I expanded it?
5 times 5 times 5 times 5.
All right, and what would this look like? What can you do when you have a 5 on the top and the bottom? What can you do with them? Cancel them out? How come?
It's basically like 1.
It's like 1. So it cancels out because 5 over 5 is really just like 1. So how many 5s can I cancel out here? 4, because I have 4 on the bottom. And then how many do I have left? Where? Up the top. Do I have to write it like this, or can I just write 5 to the 3rd? As long as it's on the top, you can just write 5 to the 3rd. What if it were flipped? You'd put a 1 on the top, and then it'd be 5 to the 3rd on the bottom. Good. Okay, so when you're dividing, you subtract. But that only works if your bases are what? The same. That's only going to work if your bases are the same. Okay? So you guys have this slide. That's what we just did. You're canceling out the 5s, 5s, 5s. So our shortcut ended up being 5 to the 7th over 5 to the 4th is the same as 7 minus 4, 5 to the 3rd. All right, the quotient of powers property, that's just what's written right here. So what would you get for A? 3 to the 6th, where?
With the 6 at the numerator.
The 6th at the numerator, or the
No, with the 3 to the 6th.
3 to the 6th at the numerator? So do I have to put it over anything? No. What about B?
It's 0, 1. I mean, it's x to 0.
X to the 0 power, which is the same as what? Good, which just equals 1. All right, what about C? So I'm going to write that just a little bigger. So you've got A to the 5th, B to the 9th, over AB to the 4th. What do you have to do first?
First, you have to distribute the 4.
First, you have to distribute the 4 on the bottom. So what do you end up with on the bottom? Somebody besides Brendan. What do you end up with on the bottom? A4, B4. And then still on the top, you have A5, B9. So then what happens when you simplify that? Subtract them. And what do you end up with? A1, B5. And both of them should be in the numerator. How come those are both in the numerator?
Because more.
There's more of them in the top, right? If you have more in the top, if you canceled out, that's where they would be left. All right, so your bigger exponent was on the top, therefore it would go on the top in your answer. All right, so A1, B to the 5th power. Can you do anything else with that? No? How come? Yeah, they're different variables. You don't know what the variables are equal to. There's no equal sign. So we're done. That's it. That's all you can do. So this is not called solving. This is called what? Simplifying. What's the difference between simplifying and solving? Solving means there's an answer. Simplifying means it's just making it simple, breaking it down as much as you can. That's all you can do. Okay. What about if we're trying to do this in scientific notation? So what if I had this problem? 2 times 10 to the 8th, 8 times 10 to the 5th. So if you have like 2 times 10 to the 8th over 8 times 10 to the 5th. Okay, so we set it up in fraction form. How come we can do that? Because fraction just means division. It means exactly the same thing. Okay, then what do you think we can do? Multiply what? We could do this. We could expand this out and figure out what that is, and it would end up being like almost 2 billion or 200 million or something like that. We could do that. But I bet there's a shortcut way to do it. We don't want to add them because what kind of math are we working with here? Subtract what, though?
8 from 5.
So we can subtract 8 from 5. If you're looking at this, you almost want to look at it like it's 2 separate problems. Like this is one of the problems, and like this is another one of the problems. So in this first problem, what does this look like? 2 over 8. Not 2 minus 8, 2 over 8, which is like what? 1/4. So this fraction is whole numbers. There's no exponents, so you don't subtract. So you just do the division there, which reduces to 1 over 4. All right, and then what? 10 to the 3 goes where? Times which, though? Where's the 10 to the 3rd? After the top? Why? Because 8's bigger than 5? Okay, 8's bigger than 5. So you could also write it like this, which is what Brendan said, 1/4 times 10 to the 3rd. You can do it. Either way, those are fine. Those are the same thing. All right? So 1/4 times 10 to the 3rd. If you did this on a calculator, this might end up as a what? Decimal. So it might also look like this, 0.25 times 10 to the 3rd power. And that's fine too. All right, so 0.25 times 10 to the 3rd. So when you're looking at it, you look at it like it's 2 separate problems. You do the division here, and then you do the division here. All right, that only works, again, if these bases are both what? The same. All right, so it's only going to work if they're both the same. Okay, try these 7, 8. Try those 8 at your boards. Okay, so when you have a quotient or a quotient with exponents, remember that you look at the numbers or the constants as if they're separate from the variables. So for example, in number 13, what did 12 over 9 reduce to? So it became 4 over 3. And then could you cancel out anything with these variables? So it just stayed 4 over 3 with x to the 3rd, y to the 8th. So look at them like they're separate problems. Because remember, when you've got stuff like this, like in number 16, if there's no sign between them, what does that really mean? Multiplication. So it's really like separate multiplication problems for all of those. Okay. What if you have a positive power of a quotient property? So what that means is, what if you have 3 over 5, which is a quotient because it's a divided one, to the 4th power? What does that look like?
It looks like 3 to the 4th power and 5.
Okay, so you can write it as either 3/5 times 3/5 times 3/5 times 3/5, like it's written right here. Or you can write that as 3 to the 4th and 5 to the 4th power. All right, so this is basically doing what with that exponent? Distributing it again to the inside, to the numerator and the denominator. So it goes with everything in the parentheses is to the 4th power. Could you simplify this one further? Yes? What's 3 to the 4th? Well, they don't have the same base, so you can't just subtract them, but what's 3 to the 4th? Yeah, 3 times 3 is 9. 3 times 3 is 9, so 81. And what's 5 to the 4th power? 625. Good. I don't need you to do that. You can leave it right here. Okay? All right. If you can do it easily in your head, go ahead and do it. If you can't, don't worry about it. Okay, so then what would A look like? 3 to the 3rd over 4 to the 3rd. Good. Can you subtract those? No, why not? They don't have the same base, so you just leave it alone. All right, what about B? Distribute it to everything that's inside of there, so there's a lot going on there. So what does the numerator become? No. 2 to the 3rd. X to the 9th. Where did the 9 come from, Diego? Yeah, it's a power to a power, so you raise it to the 9. So remember, the 3 goes with everything there. And then what about the denominator? Okay. Can you do anything with any of that? The only thing you could possibly do is 2 to the 3rd, which is what? 8. So 8x9, y3, z3. All right, and there's nothing else you can do because none of the variables are the same. What do you think happens if the power is negative? So what if you have something like this? What? Flip what? What do you mean by equation? Because I don't see an equal sign, so it's not an equation. The 2 over 3, so you flip the fraction. Why? Okay, but why? You do what? In what other ones? Yeah, whenever the variables exponents were what? What? Negative, exactly. So when you have a negative exponent, you could write this as 2 to the negative 2 and 3 to the negative 2. And we said if you want to make an exponent positive, what do you have to do? Flip it. So if it's in the bottom, it goes to the top, and if it's in the top, it goes to the bottom. Exactly. So this would become 3 to the 2, 2 to the 2 here. So you could do it like that, or you can just say, all right, so then that's 3 over 2 to the positive 2, which is 3 to the 2, 2 to the 2. It doesn't matter if you do this first or if you flip it first. All right, but if it's a negative exponent, this inside here flips, and then you distribute it. All right, so it becomes 2/3 becomes 3/2, and then the 2 gets distributed to both the 3 and the 2. Okay? The 2, which 2 becomes positive? The exponent 2 becomes positive, exactly. Because the whole point of having a negative exponent and moving it is that the exponent's no longer negative. Because we don't want negative exponents. Remember, they're ugly, they're uncomfortable, we don't want to do them. So again, I don't care which way you do it. You can either distribute the negative 2 and then flip, or you can flip it and then distribute the positive 2. I think this one's easier because it's shorter, but it doesn't matter. All right, whichever one you look at and you're like, oh, that makes sense. If you're looking at it and like neither of those make sense, just do some practice problems. Okay, so what would letter A look like?
It will look like
5 to the 3rd over 2 to the 3rd. Perfect. All right, the 5 and the 2 flipped, and then the 3 went to both of them. And it's no longer a negative 3, it's a positive 3. What about here? Same thing. So where's this 3 going to go? Bottom. And it's going to be 3 to the what? Third power. This x is going to go down, and it's going to become third power. What about the y? Goes to the top, and it's to the what power? Sixth. Why, George? Perfect. So if it's a power to a power, what do you do with them? Multiply. Exactly. And how come it's not a negative 6? You flipped it. So if you flipped it, it went from being 2 to the negative 2 and negative 3 becomes negative 6. But since you flipped it, it's positive. Great job. Okay, go do these 4.
Mind if I talk to a few of these kids real quick?